is Causal Inference in Statistics, and we're in Chapter 4, which is discussing counterfactuals. And if you'll recall, in addition to doing the questions, for this chapter we are also looking at the examples because I think that that counterfactuals are a little bit more involved than the book wanted to go into, and so they use a lot of examples to kind of not explain different ideas, but to demonstrate certain ideas. And so maybe by going through these, we can add just a little bit more than what the book provides. So, okay, so we're in example 4.4.5, and the basic setup is right here. So a policymaker wishes to assess the extent to which gender disparity in hiring can be reduced by making hiring decisions gender blind. So in other words, the people that are in charge of the hiring decisions would not know the sex of the applicants. Okay, and so this example is meant to demonstrate one of the things that we can do with so-called mediation analysis. And there's going to be more to say about mediation analysis later after we get past question 4.5.1. But here, again, we're just using one kind of tool in mediation analysis called the natural indirect effect. And so I guess we might as well look at this, but I wouldn't try to take too much about the natural indirect effect from this, but rather just maybe preparing your mind for some of the things that can be done with mediation analysis and counterfactuals. So as a first approximation, let's define the NIE, the natural indirect effect, of the effect of some variable x on y when another causal variable q is held constant. So in the context of this example, I'm going to draw a DAG here. Well, yeah, so what do I want to say about this DAG? The book does not really discuss how DAGs interface with the with this type of analysis, and so this is me trying to link things together. There is a chance that I am misunderstanding something about how DAGs interact with counterfactuals and mediation analysis, so take that for what it's worth. Okay, so the DAG that I'm imagining here is that we have a person, and that person has several attributes, and many of these we can call qualifications, and others we can call but among qualifications is not this other feature that we're interested in right here, which is their sex or their gender. Okay. Now, so what we are interested in the question is if this pathway from gender to hired is non-zero. Okay, because if that is the case, then it means that somehow in the hiring process, gender is somehow, directly affecting who gets hired. Okay. Now, so let me continue to lay on some caveats here. One of the reasons I suspect that my understanding of these DAGs and how it's going to interface with the counterfactual scenario here is the DAG that I've presented here is looking for the direct effect of gender, but we're calling it an indirect effect. And so, based on my reading of this, I suspect that the term indirect in natural indirect effect is really referring to a direct effect of something that is, I guess, incidental in the causal pathway, or something that we hope to be zero, or something like that. So anyway. So that's how I'm going to proceed. And so before going into calculating the NIE or how we might appropriately approach this, let me point out a couple of not good ideas things that would not get us the right answer. So one is just comparing the number of males and females that are hired. Okay, why would this not really tell us whether or not gender was affecting the hiring decisions? Well, because males and females could just simply apply, at different rates, to that position, right? So, so if the majority of applicants were male, well, then all else being equal, you should imagine that most of the people that are hired are male. Okay. So what if then we said, okay, well, let's compare the ratio of male and female applicants to the ratio of male and female employees or people that have been hired. Okay, well, this is a little bit better, but it's still not great, okay? Because let's say that for whatever reason, maybe it's just sampling bias, in fact, but of the males that applied and the females that applied, the most outstanding candidate is always, or not always, but most of the time, one sex or the other, right? So you could have 50 males and 50 females that have the same average level of qualification, but it could be that the best 2 applicants every time or whatever are just happen to be female, okay, for whatever reason, even if it's just random sampling bias, okay. Well, then in that case, females are going to be hired disproportionately compared to males without any bias in the decisions, okay. So those are 2 ways that we would not want to, try to determine whether or not there is, sexual bias in the hiring process. So momentarily we will try to calculate or estimate the NIE, but first let's try another approach that would work, that would be appropriate, and that's to actually run an experiment here. Okay, so in the experiment, then you can imagine that we send 50 identical, or we have 50 applications of varying levels of qualifications. Okay? And then we send those applications once, where the applicant is identified as male, and then we send the same resumes or applications where the person is identified as female. Well, now differences, between the male applications versus female applications would be due to gender. And now we could rightfully say that there was a bias here, right? Because both males and females had the exact same sets of resumes, right? So then differences would thereby reflect just differences in which sex was somehow preferred on some level by the hiring committee. But we're not doing that, right? So we're not going to run an experiment, but we are going to try to simulate that experiment statistically. So if you're familiar with linear regression, one way that you could do that is just to simply run a regression and then look for the coefficient on gender here. But what the book is trying to do is trying to make a much more give a much more general treatment of this that does not rely on the assumptions that come along with using linear regression. Okay, so how are we going to do this? Well, so the first thing that we need is the expected number of male and female applicants that are going to be hired if sex is not a factor in decision making. Okay, and so the way that we get that is with the expectation of being hired or not, right? Y, given that the sex equals some, one of the sexes. Here I think we're using male, and a set of qualifications Q. Okay. But then we also need, so that is the hiring decision if these conditions hold, these counterfactual conditions hold. But then we need to know how often those conditions hold, okay, for each gender, okay, for each sex. And so then we need to multiply the expected hiring decision by the probability of whatever level of qualification for females, and then we also need that for males, and then we take the difference between the two, and the difference is then, you know, the bias in the hiring decision. Okay, and so so our overall expression is right here. So we have the predicted number of females being hired, okay, and the predicted number of males being hired, and then we sum over all qualifications Q, all levels of qualifications Q, right? Because we don't really care about Q, we're trying to marginalize it out, right? We want to know the effect of X, so we marginalize over Q, okay? And so we can simplify this, you know, they both have this term in common, so we can just take that out, and then multiply it by the difference in the probabilities of the, you know, qualification Q prime. And then, you know, under some assumptions, you know, where there is no confounding, you know, in our DAG here, then we can rewrite that without the counterfactual expressions, just with observational data, right here. Okay. Okay. So that is, you know, a good first pass at the NIE. Like I said, in a little while, after another example and question, we'll get a little bit more into depth into NIE, as well as some of the other counterfactual applications for mediation analysis.